Imagine the night humanity finally hears it. A signal, narrow, deliberate, unmistakably artificial, threading out the dark from a single distant star. The headlines write themselves. We are not alone. Someone out there is calling. For a moment, it feels like the beginning of a conversation. But before we celebrate, one number quietly changes everything. The distance. That signal did not leave yesterday. It left centuries ago, maybe thousands of years ago, crossing space at the speed of light. And the farther the star, the older the message. What we would hear is not a voice in the present. It is a photograph of a civilization as it was, with no promise anyone still exists to answer. Tonight, we confront the gap between hearing intelligence and ever reaching it. If stories like this fascinate you and are the reason you're here, then consider tapping the like and subscribe button. Also, before we begin, we're now live on Spotify. The link's in the description if you'd like to listen to us wherever you are. Now, are you comfortable? Let's begin. The signal does not announce itself. That is the first thing to understand about the night everything changes. There is no voice. There is no greeting. There is no face resolving on a screen. No translated words scrolling across a monitor. There is only a line on a graph where there should be nothing but noise. A single narrow spike of radio energy, rising out of the static, holding steady, refusing to fade the way random interference always fades within a second or two, and vanishes back into the hiss. An antenna somewhere on Earth is pointed at one particular star, and the number coming back is wrong in the most extraordinary way imaginable. It is too clean. Nature, when it speaks in radio, is loud and sprawling and smeared across enormous ranges of frequency. Exploding stars, spinning stellar corpses, clouds of superheated gas, the tortured magnetic fields of dying suns, all of them shout across the spectrum in broad, blurred voices. What the antenna is catching instead is a whisper pitched to a single note. A tone so narrow, so surgically confined to one sliver of the radio band, that nothing in the known catalogue of natural phenomena is known to produce it by accident. For a few minutes, the people watching that line do not breathe. They have seen false alarms before. Everyone in this field has. A microwave oven opening in a break room, a passing satellite, a cell tower echoing off the dish. They know the discipline. They know the rule that has humbled every generation before them. Extraordinary claims demand extraordinary evidence, and the first instinct must always be to prove yourself wrong. So they wait. They watch the tone hold. They watch it drift, ever so slightly, in exactly the way a signal should drift if it is coming not from a transmitter bolted to the spinning Earth, but from something out there, something moving with a world of its own. And then, quietly, the thought that no one wants to say out loud begins to fill the room. We are not alone. Somewhere across the dark, something built a machine and pointed it, and sent this. Somewhere out there is an intelligence. The oldest question a conscious creature can ask, are we the only ones, has just been answered, and the answer is no. In that moment, in that room, it feels like the opening line of a conversation. It feels like the universe has finally leaned in to speak. Every human instinct screams the same thing. Say something back, reach out, answer. But before anyone reaches for a reply, someone at the far end of the room asks the one question that will quietly dismantle the fantasy of a conversation and replace it with something far stranger. How far away is the star? It sounds like a technical detail, a box to check. In truth, it is the most important question anyone in that room will ever ask, because the distance to that star is not just a measure of space, it is a measure of time. And the moment you understand why, the entire meaning of the signal turns inside out. Let us start close to home to see it. Look up at our own star. Carefully. Never directly. But picture it. The sun sits about 93 million miles away. That is not a distance light crosses instantly. Light is fast, nearly 300,000 kilometers every single second, the fastest thing the universe permits. And even at that blistering speed, the light leaving the surface of the sun takes about 8 minutes to reach your eyes. Sit with what that means. When you feel sunlight on your face, you are not feeling the sun as it is right now. You're feeling the sun as it was 8 minutes ago. If the sun was somehow to simply just switch off in this instant, you would go on seeing it shine, feeling its warmth, watching it hang there in a clear blue sky for a full 8 minutes before the darkness arrived. For those 8 minutes, you would be living inside an image of a star that no longer exists. You would be looking at the past and mistaking it for the present. That is not a trick of poetry. That is the plain physics of light. And it is happening to you every single time you step outside and squint up at the sky. You have never once seen the sun as it truly is right now. No human ever has. What you see is always a photograph, delivered 8 minutes late, of the sun. Now, push outward. Leave the solar system entirely and travel to the nearest star beyond our own, a small red ember called Proxima Centauri. It is a little more than 4 light years away. And that phrase, light year, is the key to everything. A light year is not a measure of distance the way a mile is. It is a distance defined entirely by time. The distance light travels in 1 full year. So when astronomers say Proxima Centauri is 4 light years away, they are telling you something precise and unsettling. The light arriving from that star tonight left it more than 4 years ago. You are seeing that star as it was 4 years in the past. If something dramatic happened there today, you would not learn of it for another 4 years, no matter how good your telescopes became, because the news itself can travel no faster than light. Keep going. There is a star you may know by name, a red giant that marks the shoulder of the hunter in the winter sky. There is a star you may know by name, a red giant that marks the shoulder of the hunter in the winter sky, Betelgeuse. It is enormous, hundreds of times wider than our sun, and it is old and unstable, the kind of star expected to end its life in a colossal explosion. Betelgeuse is estimated to lie roughly 500 to 700 light years from Earth, which means the light you see when you look at it tonight left that star somewhere around 5 to 7 centuries ago, around the time cathedrals were rising in medieval Europe. Here is the vertigo of it. Astronomers sometimes say, half seriously, that Betelgeuse might already have exploded. It might have detonated 3 centuries ago, or 1 century ago, or last week, and we would have no way of knowing. The flash of its death would still be racing toward us across the void, and until it arrives, we will keep seeing the living star, unchanged, exactly as it was hundreds of years before any of us were born. When we look at it, we are not looking at a star. We are looking at a memory the universe has not finished delivering. And you can push this further than any human intuition is built to handle. There is a faint smudge of light you can see with your naked eye on a dark, clear night. The Andromeda Galaxy, our great neighbor in space. It sits about 2.5 million light years away. The light landing on your retina from Andromeda tonight left that galaxy 2.5 million years ago. It began its journey before recorded history, before farming, before the first cities, before almost everything we would call human life. When that light departed, no one on Earth was looking up to catch it. Entire chapters of the human story unfolded and ended while that light was still in transit. You are, right now, capable of seeing something as it was before humanity began. Your own eyes are a time machine, and they only ever point backward. And there is one more rung on this ladder, the deepest one there is, and it puts the whole idea beyond any argument. Look past Andromeda, past the nearer galaxies, past the far ones, out to the very edge of what any instrument can detect, and you eventually run into a faint glow that comes from no star at all. It is a faint hum of microwave energy that arrives from every direction of the sky at once, remarkably even, remarkably cold. Astronomers call it the cosmic microwave background, and it is the oldest light in existence. It has been traveling for almost 14 billion years. Since a time long before Earth, long before the sun, long before the first stars had switched on anywhere. It is the afterglow of the young universe itself, released when the cosmos was only a few 100,000 years old. And it has been streaming across space ever since, stretched and cooled by the long journey until all that reaches us now is this faint, ancient hum. Think about what that means to see. When we detect the cosmic microwave background, we're looking at the universe in its infancy, the cosmos as it was before it had any structure at all, before galaxies, before stars, before there was anything in it to look back at us. There were no eyes in that universe. There was no one to see. And yet the light of that moment is still arriving, still catchable, still carrying the imprint of conditions that existed almost 14 billion years ago. It is the closest thing to a first portrait the universe will ever allow us, and we can hold it up and study it tonight. And here is the part that seals the whole idea. That ancient glow is not just the oldest thing we can see, it is, in a real sense, a wall. We cannot see past it. Not because our instruments are too weak, but because before that moment the universe was too hot and too dense to be transparent at all. A fog of raw matter and energy through which no light could travel freely. The cosmic microwave background is the first light that ever escaped that fog. It is the earliest chapter the universe permits us to read, and everything before it is sealed away behind a curtain that no telescope will ever part. And that glow still carries the faintest of patterns. It's almost perfectly smooth, the same in every direction to a remarkable degree, but not quite. Threaded through it are tiny ripples, regions a shade warmer and a shade cooler. Differences of less than 1,000th of a degree. Those ripples are the seeds of everything. The slightly denser patches were where gravity would later gather matter into the first stars, the first galaxies, the great cosmic web we live inside today. So when we read this ancient light, we are not only seeing the universe's oldest moment, we are seeing the blueprint of the one we now inhabit. I dwell on this ancient glow because it makes something unavoidable that is easy to wave away when we are only talking about a nearby star. It is tempting to think the delay of light is a small inconvenience, a few minutes here, a few years there, that clever enough technology might somehow sidestep. The cosmic microwave background closes that escape route completely. Here is direct, physical, measurable proof that the universe routinely delivers information to us that is billions of years out of date, and that there is no way around it. No shortcut, no exception. Because the delay is not a flaw in our instruments, but a feature of reality itself. Light carries the only news there is, and light is not instant. If the universe hands us a 14 billion year old glow and calls it the present view, then it will just as surely hand us a 1,000-year-old signal and call that the present view too. The rule has no small print. Whatever we catch from another star, we catch as it was. And the depth of the sky is measured not in space, but in time. This is the rule that governs the entire cosmos, and it has no exceptions. There was no such thing as seeing the universe as it is now. There is only seeing it as it was. The farther away something lies, the deeper into its past you are looking. The night sky is not a photograph of the present. It is a vast, layered archive. The sun 8 minutes old, the nearest stars a few years old, the constellations centuries and millennia old, distant galaxies millions and billions of years old, all of it arriving at once, all of it stitched together into what looks like a single moment but is actually a collage of 10,000 different pasts. Astronomy is not the study of the sky as it is. Astronomy has always secretly been a form of time travel. Every telescope is an instrument for looking into history. Now bring that rule back to the room, back to that narrow spike of radio energy holding steady on the graph. Because here is the reversal that changes everything. A signal is made of the same stuff as starlight. Not the same source. One is the natural glow of burning gas, the other an engineered transmission from a machine, but the same messenger. Radio waves are light, simply light at a frequency your eyes cannot see, and radio waves obey the same unbreakable law. They travel at that same finite speed. They take the same time to cross the same distance. An artificial signal cannot outrun its own light. It cannot skip ahead. Whatever sent it, however advanced, however clever, could not make that whisper arrive 1 instant sooner than the speed of light allows. Which means the signal on the graph is not news from the present. It is not a live broadcast. It is a photograph, exactly like the sunlight and the starlight, developed and delivered across an ocean of years. And the size of that ocean is written into that one question asked at the far end of the room. How far away is the star? Suppose the answer comes back. Suppose the source lies 1,000 light years from Earth. That is a middling distance by galactic standards. A small step across a galaxy that stretches 100,000 light years from edge to edge. But 1,000 light years means the signal left its transmitter 1,000 years ago. It departed while the technology that made it was doing whatever it was doing 10 centuries in the past. Everything encoded in that whisper, its steadiness, its precision, its deliberate design, is a report on a civilization as it existed 1,000 years before the night we finally caught it. We would not be listening to them. We would be listening to their ancestors. We would be holding a message written 1,000 years ago and only now arriving, already ancient the instant we read it. This is the heart of it, and it is worth saying with great care, because it is easy to lurch from this idea straight to a conclusion the physics does not support. The distance does not prove that anyone is dead. Let me repeat that because the temptation to skip past it is enormous. Distance does not prove extinction. It would be a mistake, a genuine scientific error, to catch that signal and declare with certainty that its senders are gone. They might not be gone at all. A stable, careful, long-lived civilization could easily persist for far longer than 1,000 years, in which case the beings who sent the signal, or their descendants, might be alive and well at this very moment. going about their existence entirely unaware that a young species on a distant blue world has just noticed them for the first time. What the distance creates is not a verdict, it is an uncertainty. A permanent, unfixable uncertainty about the present. We would know beyond doubt what that civilization was 1,000 years ago. We would know almost nothing about what it is today. And the word we might be tempted to reach for, dead, turns out to hide several very different possibilities inside it, none of which we could distinguish from the signal alone. It could mean biological extinction, the civilization simply gone, its world silent. It could mean collapse, a technological society that fell back into a state where it no longer builds transmitters, still populated, but no longer broadcasting. It could mean abandonment, that the particular machine, the particular outpost, the particular station that sent this signal was switched off or fell silent long ago, even as the civilization moved on elsewhere. Or it could mean something subtler still, the end not of the beings, but of the detectable phase, the brief window in which they happened to be shouting into space in a way we could catch. A window that may open and close in the life of any civilization, the way a single lit match flares and dies. Any of these could be true. The signal cannot tell us which. 1,000-year-old whisper carries the unmistakable proof that intelligence was there. It carries no proof whatsoever about whether intelligence is there still. And this is where the fantasy of a conversation quietly falls apart, and something more disciplined has to take its place. Because we have been sliding two completely different things together as if they were one, receiving evidence and establishing contact. They feel like the same act. They are not. They are separated by that ocean of years, and the gap between them may be uncrossable. Receiving evidence is what happens in the room that night. It is detection. It is proof, delivered, that something artificial crossed the dark and reached us. It is, by any honest measure, one of the most staggering things that could ever happen to our species. The answer to the oldest question, arriving on a graph. Establishing contact is something else entirely. Contact implies an exchange. It implies that a message goes out from us and a response comes back. That two minds meet across the distance and acknowledge each other in a shared present. And the moment you remember that our reply would also travel no faster than light, and would take another 1,000 years to arrive, and any answer another 1,000 to return, the notion of contact begins to stretch and thin until it nearly snaps. We will build to that arithmetic in full later, and it is more sobering than it first appears. For now, hold only this. Detecting them and speaking with them are not two steps of one process. They may be two entirely different categories of event, and it is possible, genuinely possible, to accomplish the first while the second remains forever out of reach. We are not, it should be said, working from pure imagination here. We've already begun rehearsing for this exact moment, and we have done it recently, in a way that shows how the instinct plays out in real life. In the summer of 2025, astronomers spotted an object falling through our solar system on a path that could only mean one thing. It had come from beyond. It was the third confirmed interstellar visitor ever found, after the strange elongated wanderer nicknamed Oumuamua and the comet called Borisov before it. This new one was given the designation 3I Atlas, and the moment it was confirmed as a genuine object from another star system, something revealing happened. Within about a day, telescopes across the world and instruments across the solar system swung toward it. Spacecraft that happened to be in useful positions were pressed into service. Radio astronomers pointed their dishes at it and listened carefully for any hint of a signal, any narrow tone, any structured emission, anything that ordinary natural physics could not explain. They did this not because they expected to find a machine. They expected correctly to find a comet. An ancient icy body, by some estimates older than the sun itself, carrying the frozen chemistry of a solar system that formed before ours. And that is exactly what the evidence showed it to be. A natural object, its unusual features fully explained by nature. But notice what that scramble demonstrates. The instant something crossed into our space from the outside, our first reflex was to interrogate it, to ask, with real instruments and real rigor, could this be technological? And if it is not, how do we prove that cleanly? That reflex is the rehearsal. 3I Atlas was a physical object we could watch and photograph as it passed. A signal is something else. It is not an object we can revisit, not a rock we can track for months, but a fleeting pattern of energy that has already traveled unimaginably far and may pass through our antennas only once. The habits we are building now, on comets and interstellar drifters, are the habits we will need on the night the pattern is not a comet at all, but a tone that nature cannot make. So return one last time to that room, to that steady spike on the graph, and to the reversal we have just performed on it. What began the evening looking like the start of a conversation now looks like something profoundly different. It looks like an artifact, a dated object, sealed by distance, carrying certain proof of intelligence in its past and total silence about its present. The euphoria in the room is real and it is earned. But underneath it, for anyone who has followed the logic, a colder awareness is settling in. We may have just discovered that we were never alone in the universe. And we may, in the same breath, have discovered that we can never be sure anyone is still out there to hear us say so. But all of that assumes the signal even makes it to us intact, that a whisper aimed across 1,000 light years of emptiness can survive the journey at all, and still look like a whisper when it arrives. And that is not a small assumption. Space is not empty in the way we imagine. A signal launched into it does not simply glide across untouched and land in perfect shape on our antenna. It spreads, it weakens, it thins out across the widening dark until it is fainter than the faintest breath. It fights against a roaring background of natural noise and a storm of interference of our own making. Most of what any civilization ever radiates into space would dissolve into undetectability long before it reached a neighbor. And yet certain kinds of signals, built and aimed a certain way, could survive across distances that ordinary emissions never could. So before we can ask what a signal means, we have to ask how a signal survives. What actually happens to that whisper on its long crossing through the dark? And why, out of everything a civilization might send, only a narrow few kinds could ever reach us at all? That is where we go next. The whisper has to survive a crossing that ought to kill it. We began standing in that room, staring at a narrow spike of radio energy and calling it a message from the past. But we skipped over something enormous in our hurry to marvel. We assumed the signal arrived intact. We assumed it left its distant transmitter looking like a clean, sharp tone and reached our antenna still looking like a clean, sharp tone, as though space between the stars were a quiet hallway down which a shout travels unchanged. Space is nothing of the kind. A signal launched across the galaxy is less like a shout down a hallway and more like a message in a bottle thrown into a vast, churning current. And by the time that bottle washes up on a far shore, the odds are overwhelming that it has been battered into nothing, or thinned to a smear no one could ever read. To understand what it means to catch a signal at all, we first have to understand everything the universe does to erase one. Start with the simplest and most merciless problem: distance drains strength. When a transmitter sends energy into space, that energy spreads outward, and as it spreads, it thins. Picture a single drop striking the surface of a still pond. A ring races outward from the point of impact, and as the ring grows wider, the height of the ripple shrinks, until far from the center the wave is so flat you could not tell it from stillness. Radio energy does the same thing in 3 dimensions, expanding in an ever larger sphere, and the law that governs it is unforgiving. It is called the inverse square law, and what it says is this: double your distance from a transmitter, and the signal is not half as strong. It is 1/4 as strong. Move 10 times farther, and the signal is 1/100th as strong. Move 1,000 times farther, and it is 1/1,000,000th. The strength does not decline gently. It collapses. A transmitter that would deafen you standing beside it becomes, at interstellar range, fainter than the faintest thing our instruments can register. Its power divided and subdivided across a sphere so large, the numbers stop meaning anything. You might think the answer is simply to aim the signal, to stop wasting energy in every direction, and instead focus it into a tight beam pointed straight at the target. And that helps enormously. But even a beam spreads. There is no such thing as a perfectly parallel beam of light or radio. Every beam fans out with distance, however slightly, and across the gulf between stars that slight fanning becomes vast. A beam that leaves its source only a few meters wide can arrive, light years later, wider than a whole planet, wider than a star, its energy smeared across a region so enormous that any single antenna catches only the tiniest sliver of what was sent. The transmitter poured out a flood. We stand 1,000 light years downstream and manage to catch a few drops on the tip of a needle. That is the reality of it. Detection is not receiving a signal. Detection is catching a rumor of a signal that has been diluted almost, but not quite, out of existence. So if strength is bleeding away this fast, how could we ever catch anything at all? The answer is the single most important idea in this entire search, and it is the reason those people in the room dared to get excited in the first place. The trick is not loudness, the trick is narrowness. Here is the distinction. Nature, when it broadcasts in radio, is a spendthrift. The natural processes that light up the radio sky, the churning of magnetized gas, the shock waves of dying stars, the vast cold clouds drifting between the stars, all pour their energy out across enormous ranges of frequency at once. Natural radio is broad. It is smeared across the spectrum in wide, blurry bands, because the physics that makes it is chaotic and diffuse. This is nature's fingerprint, and it is everywhere. To find a signal that nature did not make, you look for the one thing nature almost never does. You look for energy crammed into an impossibly thin slice of frequency. A single, pure, razor-narrow tone. Think of it as a needle of a single tone standing up out of an ocean of static. The ocean is nature, broad, restless, roaring across every channel. The needle is something else, a note so pure, so confined, that no known natural process concentrates power that way by accident. And narrowness does something wonderful for the searcher. because a natural background is spread thin across the whole spectrum, while an artificial tone piles all its strength into one hair's width channel. That tone can stand out against the roar even when its total energy is faint. It is the difference between a whisper lost in a crowded, noisy hall and the same whisper heard clearly because it is pitched to a single note. No one else is singing. This is why radio searchers obsess over narrowband signals. It is not that intelligence must use them. It is that narrowness is the one clear flag that says, this did not come from the blind machinery of physics. Something made this on purpose. But knowing to look for a narrow tone only tells you what shape to hunt for. It does not tell you where on the dial to point. And that turns out to be a problem almost as large as detecting the tone in the first place. The radio spectrum is enormous. A civilization could, in principle, transmit on any of billions upon billions of possible frequencies, and we cannot listen to all of them at once with anything like the sensitivity we need. So we face a strange puzzle. If you wanted to be found by someone you had never met, someone with whom you had never exchanged a single word, what frequency would you choose? And how would they ever guess it? This is not a hopeless question, and the reason is beautiful. Imagine two strangers told to meet somewhere in a vast, unfamiliar city on the same day, with no way to communicate and no arrangement made in advance. It sounds impossible, and yet, remarkably often, both will reason their way to the same obvious landmark, the one place that stands out so plainly that each trusts the other will think of it too. There are natural landmarks in the radio spectrum in exactly that sense. The most famous sites near the frequency at which hydrogen, the most abundant substance in the universe, naturally emits, a channel every technological species anywhere would discover early, because they would be studying the same hydrogen we are. A thoughtful sender might reason, our neighbors cannot read our minds, but they can read the same physics, so let us transmit near the one frequency the whole galaxy has in common. And a thoughtful listener makes the mirror image guess. It is not certainty. It is a shared bet on the obvious, placed by two minds who have never met, and it tells us where to point first. But a pure tone alone is not enough, because a real signal from a real world carries other fingerprints, and one of them is motion. A transmitter does not sit frozen in space. It rides on a spinning planet, or orbits a star, or drifts on some moving structure, and all of that motion shifts the frequency of the signal as it travels. The same way the pitch of a siren rises as it races toward you and falls as it speeds away. Across the hours we might watch a signal, its frequency will slowly slide, drifting up or down as the transmitter's motion changes relative to us. This drift is a clue and a filter both. A source of interference bolted to the Earth drift in its own characteristic way, tied to our planet's motion and our own machinery. A signal born on a distant, independently moving world drifts differently. So the searcher does not just ask, is this a narrow tone? The searcher asks, does it drift the way something out there would drift, rather than the way something down here would? The pattern of the drift becomes part of the signature. Now layer on the noise, because we have been describing this hunt as though space was silent, and it is anything but. There is a floor of natural noise everywhere, the faint hiss of the cosmos itself, the glow of our own galaxy and radio light, the thermal murmur of the instruments doing the listening, and then, far louder and far worse, there is us. We have wrapped our planet in a roaring shell of our own radio racket. Satellites overhead chatter constantly. Phones, radar installations, aircraft transponders, television towers, wireless everything, and yes, famously, the humble microwave oven, all of it spraying radio energy in every direction. This is called radio frequency interference, and it is the single greatest obstacle in the entire search. Because here is the cruel symmetry. The very kind of signal that would excite us most, a narrow, drifting, artificial-looking tone, is exactly the kind of signal our own technology produces by the millions. We are trying to hear a candle flickering across 1,000 light years while standing inside a stadium full of floodlights of our own making. The faint true signal and the deafening false ones look, at first glance, maddeningly alike. Which brings us to a question that reshapes the whole search once you take it seriously. Out of everything a civilization might radiate into space, what kind of signal could actually reach us? And what kind would dissolve long before it ever arrived? Consider our own world as the example, because it is the only one we have. For about a century now, Earth has been leaking radio energy into space. Our broadcasts, our radar, our communications, a great deal of it escapes upward and outward, spilling into the dark in all directions. People sometimes imagine this leakage as a proud, expanding bubble announcing humanity to the cosmos, our old television broadcasts sailing outward to be caught by curious neighbors. The truth is far humbler. This leakage is weak, and it is scattered in every direction rather than aimed, and it is spread across many frequencies rather than concentrated. It's a spark lost in daylight. Run it through the inverse square law, let it fan out and thin across even a modest interstellar distance, and it sinks beneath the natural noise floor and vanishes. A civilization with instruments like ours, sitting at the distance of even a nearby star, would almost certainly not detect Earth's ordinary leakage at all. It is simply too faint, too diffuse, too unfocused to survive the crossing. Our everyday radio noise does not travel forever, growing fainter but forever catchable. It fades into undetectability far sooner than most people imagine, drowned by the very static of space. Now imagine a different kind of signal, not leakage, not accidental spillover, but a deliberate beacon. A transmitter built for one purpose, to be seen. It concentrates enormous power into a narrow band, the way you would concentrate all a room's scattered candlelight into a single signal fire built to be noticed from a distant hill. It aims that power into a tight beam rather than wasting it in all directions, and that focus multiplies its reach dramatically. This is where the idea of effective radiated power comes in. A way of describing not just how much raw energy a transmitter puts out, but how much it appears to put out in the direction it is aimed, once you account for how tightly it is focused. A modest transmitter, sharply aimed, can appear from the target's point of view to be blindingly powerful. A deliberate beacon of this kind could remain detectable across distances hundreds or thousands of times greater than ordinary leakage could ever manage. Hold on to that difference because it quietly bends the whole story. It means the first artificial signal we detect is far more likely to be a deliberate, powerful, aimed beacon than a scrap of eavesdrop chatter. We are not likely to overhear civilization's private conversations by accident across 1,000 light years. If we catch anything, we most likely catch something that was built to be caught, something loud on purpose. And a thing built to be caught can be built to keep broadcasting long after its makers stop tending it. A beacon can be automated. It can run on the energy of its star. It can be, in effect, a machine left switched on. We will return to what that implies in the next part, but plant the seed now. The signals most likely to reach us across the greatest distances are exactly the signals most capable of outliving whatever built them. And radio, for all our focus on it, is not the only way to shout across the dark. There's another channel entirely, one that trades the broad reach of radio for something radio can never do. A blinding, momentary brightness. Instead of a steady tone, imagine a pulse of laser light, a flash so brief it lasts only a billionth of a second, but so concentrated in that instant that, for that single sliver of time, it can outshine the sender's own star. Picture a flashbulb going off right beside a bonfire. The bonfire pours out vastly more total energy, but in the instant the bulb fires at the single color it fires in, the flash wins. A civilization aiming such pulses at a target could produce a beacon that is invisible almost all the time, and then, for a nanosecond, unmistakable, a spike of light at one pure color, far too brief and far too bright at that color for any star to counterfeit. Detecting such a thing calls for completely different instruments than radio. Not dishes listening for tones, but sensitive optical detectors watching for flashes faster than the eye or an ordinary camera could ever register. Searches like this exist, quietly scanning for pulses that last a heartbeat of a heartbeat. And a laser pulse carries the same hard truth as everything else in this story, no matter how brilliant it is in its instant. It still travels at the speed of light. It still left its source 1,000 years ago if its source lies 1,000 light years away. A dazzling flash and a faint radio whisper arrive burdened with the identical delay. Brightness buys distance. It does not buy time. And there is one more property that decides everything about whether a detection ever becomes a discovery. Repetition. A signal that appears once and never again is, scientifically, almost useless, no matter how thrilling it was in the moment. This is the hardest lesson the search has learned, and it learned it early on the most famous candidate in its history. On a summer night in 1977, a radio telescope in Ohio nicknamed the Big Ear was sweeping the sky. And for about 72 seconds it caught something extraordinary. A strong, narrow signal rising and falling in exactly the pattern you would expect from a fixed point in deep space, passing through the telescope's field of view as the Earth turned. It sat near 1,420 megahertz, precisely the hydrogen frequency we singled out earlier as the galaxy's natural meeting point. The obvious channel a listener would check first. Arriving exactly there was part of what made it so electrifying, and part of why it has never been forgotten. When an astronomer later reviewed the printout and saw how far the reading towered above the background, he circled it and scrawled a single word beside it: wow. The signal has been called the wow signal ever since. By every checkbox on the list, it looked right. It was narrow. It was strong. It sat on a frequency that made sense. It behaved like a source out in space rather than a source on the ground. And then it did the one thing that damns any candidate forever. It never came back. The Big Ear looked again. Other telescopes looked. People have looked for it for decades. It has never reappeared, not once. And because it never repeated, it can never be confirmed, and it can never be dismissed. It is frozen permanently in the category of the unknown, too clean to explain away, too fleeting to verify. That is the fate of the one-time detection. Without repetition, there is nothing to point back at, nothing to study, Nothing to hand to another observatory and say, "Look here, tell me what you see." A signal you cannot find twice is a signal you can never truly claim. Repetition is the currency of proof, and the wow signal never paid it. Contrast that with what a repeating signal allows, and you understand why the confirmation process is so relentless, and why real detection is never a single flash of eureka, but a long, deliberate gauntlet of elimination. Because before anyone can announce a signal as alien, they have to rule out everything else it could possibly be. Terrestrial interference, natural phenomena, instrument error, and simple coincidence. And the search has learned, painfully, how good false signals are at wearing the costume of a real one. The clearest lesson came in 2019 from a candidate known as BLC-1. Astronomers using the Parkes telescope in Australia were watching Proxima Centauri, the nearest star to our own, and in the data they found something that made hearts race. A narrow signal near 982 MHz that persisted not for seconds, but for hours. It drifted in frequency, slowly and steadily, the way a signal from a moving world should drift. It appeared when the telescope was pointed at the star and seemed absent when the telescope pointed away. Exactly the behavior you would demand of a genuine source in that direction. It was, by a wide margin, the most compelling candidate in years. It looked like everything a real techno-signature was supposed to look like. Their instruments were sensitive enough that, had it been real, it implied a transmitter with an effective, radiated power of only a couple of gigawatts. Well within what a civilization might build, pointed from the nearest star. And it was not real. It took painstaking work to prove it, and that work is the whole point. When researchers examine the signal with a careful verification framework, asking not just does it look right, but does anything else on Earth produce signals like this, they found their answer. BLC-1 was not a message from Proxima Centauri. It was an electronically drifting artifact of local interference, a phantom born from the way ordinary human electronics can beat against one another and produce a drifting tone at just the wrong frequency, aligned with the rhythm of the observations. They even found many similar false signals scattered nearby in the data, at frequencies tied to the ordinary oscillators inside common equipment. Everything that had made BLC-1 exciting, the narrowness, the persistence, the drift, the apparent tie to the target, had been mimicked perfectly by our own machinery. That is how convincing a false positive can be. It can pass filter after filter and still, in the end, be nothing but us, listening to the echo of our own devices and briefly mistaking it for the stars. And so the modern search treats confirmation not as a celebration, but as an act of ruthless subtraction, the systematic stripping away of every possible imposter, until either nothing is left, or something impossibly stubborn remains. The best recent illustration is not a signal from a star at all, but the way we responded when that interstellar visitor, 3I Atlas, came falling through our solar system in 2025. When it was confirmed to have come from beyond, a team pointed the Allen Telescope Array in Northern California at it and listened across a broad span of radio frequencies from 1 to 9 gigahertz for more than 7 hours, specifically hunting for any narrowband tone that nature could not produce. And watch what the numbers do, because they tell the entire story of this work in miniature. The search pulled in roughly 74 million narrowband hits. 74 million. An overwhelming majority were identified almost immediately as human-made interference. Our satellites, our transmitters, our noise. After stripping those away and keeping only signals that match the object's own motion through the sky, the 74 million collapsed to about 200 candidates. And when those final 200 were examined one by one, every single one fell. 0 technosignatures remained. The object was, as expected, a natural comet, an ancient one, older than the Sun, but natural through and through. That is what real detection looks like from the inside. Not a bell ringing and a room erupting, but 74 million down to 200, down to 0. Each number a mountain of elimination. And the scientist who led that search made an observation worth carrying forward. In paraphrase, our own Voyager probes will one day drift into other star systems and become, to whoever finds them, alien artifacts. So we had better understand exactly what natural objects look like, precisely so that we could recognize an unnatural one if it ever appeared. The search is not really built to find aliens. It is built to rule out everything that is not aliens. So thoroughly that if something ever survives the gauntlet, we would be forced to take it seriously. It is worth being precise about what that gauntlet would actually involve, because the popular image of discovery, a lone scientist, a bell ringing, an announcement to the world within the hour, is almost the opposite of how it would really unfold. A genuine candidate would enter something closer to a chain of custody, the careful, documented handling that evidence passes through before a court will trust it. The first team to see the signal would not be permitted, even by their own standards, to believe themselves. They would ask other observatories on other continents, using other equipment, to point at the same patch of sky and see whether the signal was still there, because a real source in space would appear in all of them, while interference tied to one location or one instrument would not. They would check whether the signal moved across the sky the way something beyond Earth must move as the planet turns. They would run the raw data through independent analysis pipelines built by rival groups who would be delighted to find the mistake. They would hold the announcement deliberately, painfully, until the candidate had survived all of it, because they would know that a false alarm broadcast to the world would poison the search for a generation. There are agreed protocols for exactly this, worked out in advance precisely so that no one has to improvise in the most important moment in scientific history. Confirmation, in other words, is not a flash of certainty. It is a slow, adversarial, cross-checked verdict, and only a signal that survives every challenge earns the right to be called real. So now imagine that it does survive. Imagine the impossible thing has happened. A signal has appeared and reappeared. It has been caught by more than one instrument on more than one night, pointed at more than one place, and every ordinary explanation has been hunted down and killed. It is not a satellite. It is not a microwave oven. It is not a drifting artifact of our own electronics. It is not a comet, not a pulsar, not the hiss of gas or the ring of a struck instrument. It is narrow the way nothing natural is narrow. It drifts the way something on a distant world would drift. It repeats, so it can be studied. It has passed through the gauntlet of elimination and come out the other side still standing. And the people who would most love to debunk it have run out of ways to try. It is, as far as the whole apparatus of science can determine, real and artificial, and from another star. That night would be the greatest in the history of our species, and it would also be the beginning of the hardest problem we have ever faced. because surviving the gauntlet only proves that the signal is genuine and made by intelligence. It proves nothing at all about what the signal contains, or what it can tell us, or, most of all, whether anyone is still there behind it. We would hold in our hands a verified message from the deep past, and we would immediately have to ask a new and far more disturbing set of questions. What can this thing actually reveal? Its direction, its age, its rhythm, its structure, the world it came from. How much of that could we read? And which of those questions, no matter how powerful our instruments or how patient our study, would remain forever beyond our reach? That is where we turn next, to everything a confirmed signal could tell us, and to the one thing it never could. Suppose it survives. Suppose the impossible night we imagined at the close of the last part has arrived and held. The signal repeated. It was caught by more than one instrument on more than one night. Every imposter was hunted down and killed. It is narrow the way nothing natural is narrow. It drifts the way a distant world would drift. And the people who would most love to debunk it have run out of ways to try. It is real, and it is artificial, and it is from another star. Now the celebration has to give way to a colder kind of work, because a confirmed signal is not an answer. It is a locked box. And the question that will consume every scientist on Earth from that night forward is deceptively simple. How much of what is inside that box can we actually read? And how much will stay sealed no matter what we do? To think about this clearly, we have to lay out the stages of contact honestly, because we have been letting them blur together, and the blur is where all the false hope hides. Detecting an unusual signal is one thing. Confirming that it is artificial is a second, separate thing. That was the whole gauntlet of the last part. But even a confirmed artificial signal is only the second step on a much longer staircase. After confirming it is artificial, we would still have to determine where and when it came from. Then, we would have to decode whatever information it carries, if it carries any at all. Then, and this is the step everyone skips, we would have to establish whether the civilization that sent it still exists. Only then could we even consider sending a reply, and only after that could we hope to receive a response. Detect, confirm, locate and date, decode, determine if they live, reply, receive. 7 stages, not one. And they are not a smooth escalator carrying us upward from one to the next. Each is a separate problem, and some of them may have no solution at all. It is entirely possible to complete the first 4 and find the 5th permanently, physically closed. So let us do the honest accounting. Let us go through what a confirmed signal could genuinely tell us, and it is a great deal more than you might expect, and then arrive at the single thing it cannot. Start with direction, because direction comes almost for free. To detect the signal at all, we had to point at it, which means we know roughly where in the sky it lives. With enough observatories cooperating, that direction can be sharpened until it lands on a specific patch of sky, and with luck on a specific star. That alone is staggering. A named address in the galaxy. A particular sun we could turn every telescope we own toward, and study in detail. We could learn the type of star it is, its age, its temperament, whether it is a calm, long-burning ember, or a violent flaring youth. We could begin, in time, to hunt for planets around it, to measure their sizes and orbits, perhaps even to sample the light filtering through their atmospheres. The signal would hand us not just proof of intelligence, but a place to point our entire civilization's curiosity. And embedded in that direction is the distance. And embedded in the distance, as we saw earlier, is the age. The moment we know the source lies, say, 1,000 light years away, we know the signal is 1,000 years old. And we know we are reading a report filed 10 centuries in the past. Direction gives us the where. Distance gives us the when. Both are readable. Both are, in a real sense, easy. Now go deeper into the signal itself, into its texture, because there is information encoded in its very shape. Consider its bandwidth, how narrow the tone truly is. An extraordinarily narrow signal tells us something about the precision of the technology that made it, and about how far it has travelled, because the long passage through the thin gas and magnetic fields between stars leaves subtle fingerprints on a signal, smearing and scattering it in ways a careful analysis can partly read. In principle, the distortion stamped onto the signal by its journey could corroborate the distance we measured. An independent check written by the interstellar medium itself. Consider its energy. From the faint whisper we catch and the distance we have measured, we can work backward to estimate how powerful the original transmitter must have been, and therefore something about the scale of the effort behind it. A signal implying a modest transmitter suggests one kind of civilization. A signal implying a beacon blazing with the output of a substantial power source suggests another entirely. Consider its structure. Is the tone perfectly steady, or is it modulated? Switching and shifting in patterns. A pure, unchanging tone might be nothing more than a marker, a cosmic signpost saying only here, here, here. But a tone that varies in structured ways is a tone that might carry content. And content is the thing that sets every imagination on fire. And consider repetition, which we met at the end of the last part as the currency of proof, but which is also a source of meaning in its own right. Does the signal pulse on a schedule? Does it return every few hours, every few days in a rhythm? A regular repetition suggests automation, a machine faithfully executing a cycle. An irregular one suggests something else. The pattern of return is itself a message about the nature of the sender, before we decode a single bit of whatever it carries. Which brings us to the most tantalizing possibility of all, that the signal contains actual information, that woven into its structure is something meant to be understood. Mathematics, perhaps. The one language we might genuinely share with a mind shaped by a different world, since a prime number is a prime number everywhere in the universe, and the ratios of chemistry hold in every star system. Decoding such a thing would be the labor of a generation, maybe generations, an undertaking without precedent. But it is not obviously impossible. If the senders wanted to be understood, they may have built the message to be decodable by anyone clever enough to catch it, starting from the shared bedrock of number and physics and building upward. We might, after years of work, begin to read it. We might learn something of who they were, their science, their picture of the cosmos, perhaps something of their history or their hopes. It is the most extraordinary prize the search could offer. But wanting to read a message and being able to read it are separated by one of the hardest problems imaginable, and it is worth sitting with the difficulty rather than waving it away. We will be handed a stream of structure with no dictionary, no grammar, no shared word, no common history, nothing that every human translator has always been able to lean on when cracking an unknown script on Earth. Every ancient language we have ever decoded, we decoded because it was human. Written by people with human concerns, often with some bridge to a known tongue, describing a world we already understood. An interstellar message offers none of that. Its senders may perceive the world through senses we do not have, think in categories we cannot picture, and carry a history with no point of contact to ours. And yet, it may not be hopeless, for one reason. There is a bedrock beneath every possible mind in the universe, and it is not language. It is mathematics and physics. A prime number is a prime number on every world. The count of the simplest atoms, the ratios that govern light and chemistry, the plain truths of geometry, these do not change from one star to another, because the universe does not change from one star to another. A sender who genuinely wished to be understood could build the message the way you build a staircase, starting from a first step so simple and so universal that any mind clever enough to catch the signal could stand on it. A handful of counted pulses, a prime, a basic ratio, and then adding step after step, each resting on the last, teaching its own code as it climbs. A message like that would be, in effect, self-teaching. A ladder whose first rung is a number, designed so that the very act of reading it hands you the tools to read the rest. Decoding it would still be the labor of years, perhaps of a generation handing the work to the next. But it is the one translation problem where the two parties, though they have never met and never can, already share the entire foundation of number and natural law. That shared flaw is the only reason the attempt is not doomed before it begins. And here is where we must stop the momentum cold, because notice the tense. Who they were. Everything on that list. The direction, the distance, the age, the bandwidth, the energy, the structure, the repetition, even the fully decoded content. Everything describes the source as it was when the signal left. Every single readable property is a property of the past. The box, no matter how much of it we open, contains only history. And there is one question the box cannot answer, no matter how completely we read it, no matter how brilliant our decoding, no matter how many observatories we point or how many years we study. Does anyone still exist behind it? This is the wall, and it is worth seeing exactly why it is a wall, and not merely a hard problem. Every clue the signal offers is a clue about the moment of transmission. The signal is a sealed, dated envelope, and everything written inside it was written on the day it was sealed. It cannot contain news of anything that happened after it departed, because nothing can travel faster than the signal itself to update it. If the senders flourished for another 1,000 years after they transmitted, the signal cannot say so. That later flourishing has not reached us yet, and will not for 1,000 years more. If they vanish the century after they transmitted, the signal cannot say that either, because a silent civilization sends nothing, and the absence of a follower proves nothing across distances where even a healthy civilization might broadcast only rarely. The present state of the source is not faint in the signal, or hidden in the signal, or encrypted in the signal. It is simply not in the signal at all. It could not be. The physics forbids it. And this is where we have to handle the word that hangs over this entire subject with real care. Because the temptation, once you feel the weight of that wall, is to leap to the darkest reading and call the senders dead. Resist that leap. The wall does not prove extinction, it proves uncertainty, a permanent, unfixable uncertainty about the present. The senders might be perfectly alive. A stable civilization could easily outlast the 1,000-year journey of its own signal and be thriving at this very moment, unaware that we have finally noticed them. What the distance guarantees is not that they are gone, but that we cannot know whether they are gone. Those are profoundly different claims, and the difference is the whole honest heart of this story. Now, let us make the wall concrete with the arithmetic we glimpsed earlier and deliberately held back, because until you run the numbers, the abstraction of it stays comfortable, and it should not stay comfortable. Take our example, distance, 1,000 light years. The signal we caught tonight left its source 1,000 years ago. That is fixed. That is the age of the evidence. Now, suppose we decide to answer. Suppose the very night we confirm the signal, we point our most powerful transmitter at that star and send a reply at the speed of light, nearly 300,000 kilometers every second, the fastest anything can move. That reply does not arrive next year. It does not arrive next century. It travels for 1,000 years before it reaches the source, assuming the source is even still there and still listening and still capable of catching it. And if someone at the other end receives our reply and immediately answers back, their answer takes another 1,000 years to return to us. Add it up. From the moment we first observed the signal to the earliest moment we could possibly receive a response is roughly 2,000 years. 2,000 years for a single round trip. One question, one answer, and 20 centuries gone. Sit inside that number for a moment, because the human mind slides right off it. 2,000 years ago on Earth, the Roman Empire was young and powerful. Every language you speak, every nation you know, every institution, every technology in your life did not exist. If a civilization 2,000 years ago had sent us a question and we were only now, tonight, receiving it and preparing our reply, imagine what would have to survive on our end just to complete the exchange. The senders would have had to remain a continuous, coherent, listening civilization across the entire span from the Roman world to now, through every collapse, every dark age, every reinvention, never losing the thread, never forgetting they were waiting, never losing the ability or the will to catch a whisper from the sky. That is what a conversation across 1,000 light years actually demands. Not patience, not even institutions. It demands a continuity of purpose across spans of time longer than any human civilization has ever sustained anything. A conversation is not too slow across such distances. A conversation may simply be the wrong word for what is possible at all. So we are left holding a verified signal, rich with readable history, and utterly silent about the present, and separated from any reply by a gulf of centuries, which forces the real question of this part into the open. If the signal cannot tell us whether its makers still exist, what are the actual possibilities behind it? What kinds of things could be sending us proof of intelligence across 1,000 years of darkness? There are 4, and they range from the hopeful to the haunting. And the crucial point is that from the signal alone, we very likely could not tell which one we were looking at. The first case is the one we all want. A living civilization, transmitting deliberately right now. Or rather, transmitting 1,000 years ago and still transmitting today, still there, still broadcasting. A mind on the other end of the line, even if the line takes 20 centuries to complete a single exchange. In this case, the signal is exactly what it feels like. A hand extended across the dark by beings who are still alive to extend it. This is the best outcome, and it is genuinely possible. We cannot rule it out. And this is the whole problem, we cannot confirm it either. Not from the original detection, because a living transmitter and a long-dead one can produce the identical signal arriving at our antenna tonight. The second case is stranger, and the more you consider it, more likely than it first appears. An automated beacon, still broadcasting after its makers are gone. Remember what we saw earlier. The signals most likely to reach us across the greatest distances are deliberate, powerful, aimed beacons. And a beacon can be a machine. A machine can be built to run on the energy of its star. A machine can be built to endure, to repeat its cycle faithfully for millennia, with no one tending it. It is entirely conceivable that a civilization, at the height of its powers, built such a beacon precisely so that its existence would be known long after it was gone. A lighthouse left burning on an abandoned coast, its keeper long dead, its lamp still turning. If that is what we caught, then the signal is authentic, and the intelligence behind it was real, and the beacon is still faithfully doing its job. And there is no one home. The message is a machine outliving its makers. This is the leading reason the title's unsettling possibility is more than melodrama. The very durability that lets a signal cross the greatest distances is the same durability that lets it outlast the hand that built it. The third case is the accidental one. Leakage from the past, not a beacon at all, but the ordinary radio spillover of a civilization going about its business. The way Earth has leaked for a century. We saw earlier that ordinary leakage is usually too faint to cross interstellar distances, and that remains true. But a civilization more powerful than ours, or one caught at a particular loud moment of its history, might have leaked strongly enough for a slice of it to reach us. And if so, what we would be catching is a fragment of their everyday life, escaping outward, arriving 1,000 years late. In this case, the signal was never meant for us at all. We would be eavesdropping on a moment already 1,000 years finished, overhearing a world that was simply living, unaware that its noise was drifting toward a distant world that would one day strain to catch it. And that living moment could have been the civilization's dawn or its final century. The leakage cannot tell us which. The fourth case is the one that changes the shape of everything, and it is where this part has been quietly heading. What if the most durable evidence of intelligence is not a signal at all? A signal, however powerful, is fragile in one specific way. It must be actively produced. Something must be running the transmitter. The moment the machinery stops, whether because the makers died, or the beacon failed, or the power ran out, the signal ends. And after that, only the last of it, already in flight, continues to arrive before falling silent forever. But some things a civilization might make are not like that. Some things persist on their own, radiating evidence of themselves passively, whether or not anyone is left to maintain them. And those things could outlast any broadcast by an enormous margin. Consider a civilization that grew hungry for energy and began to capture the output of its own star, building a vast swarm of structures to intercept starlight, what has long been imagined as a Dyson sphere, or more realistically a Dyson swarm of countless collectors orbiting the star. Here we cross from confirmed physics into leading hypothesis and beyond. So let me be careful about the labels. That such structures are physically conceivable is sound reasoning, not established fact. We have never confirmed one exists. But the logic of how we might detect one rests on solid physics. Any structure that captures starlight and puts it to use must, by the ironclad laws of thermodynamics, re-radiate the energy as waste heat glowing in the mid-infrared. The same reason your own body glows in infrared. The same reason a machine that has been running warms the air around it. So a star wrapped in a swarm of collectors would look strange, dimmed in ordinary light, because the collectors block some of it, and unusually bright in the mid-infrared, because the captured energy leaks back out as heat. That combination is a fingerprint, and crucially, it is a passive fingerprint. The structure does not have to be aimed at us. It does not have to be switched on for our benefit. It simply glows in every direction for as long as it physically exists, which could be far longer than the civilization that built it. This is not merely a thought experiment. We have already begun looking. A survey called Project Hephaestus combed through the light of roughly 5 million stars, hunting for exactly this signature, the telltale excess of mid-infrared glow that a partial swarm might produce, and identified 7 candidates with a closer look, all of them small, cool M-dwarf stars whose infrared excess was not easily explained by ordinary causes. Now, honesty demands the rest of the sentence, and it is the important part. Those 7 candidates are almost certainly not alien megastructures. Follow-up work suggests the excess glow is most likely contamination. Distant background galaxies of a particular dusty, infrared bright kind, sitting by chance in the same line of sight and masquerading as a warm structure around a nearby star. The leading interpretation now is that these are natural coincidences, not engineering, but hold on to what the exercise demonstrates rather than what it found. It demonstrates that we are already scanning millions of stars for the passive, durable, heat glow evidence of technology. Evidence that, unlike a broadcast, would keep announcing itself long after any broadcast had stopped. A beacon can be switched off. A structure the size of a solar system cannot simply vanish. Its heat would linger. Its shadow across its star would linger. It would go on radiating the fact of its own construction into space for ages after its builders were gone. There is a subtler passive fingerprint too, one that does not require building anything in space at all. A civilization that industrializes will change the air of its own world, and some of those changes are not easily undone and not easily hidden. Burn enough, manufacture enough, and a planet's atmosphere fills with substances that nature does not readily produce on its own, and a few of them, certain long-lived synthetic gases in particular, can linger for centuries or longer and have no plausible natural source at all. We can already read the atmospheres of distant worlds in a limited way by catching the starlight that filters through them and noting which colors the gases drink up, each gas leaving its own signature in the light. A world whose air carried the unmistakable stain of industry, a compound that only technology makes, would be advertising the past presence of technology to anyone patient enough to read its light. And notice the quality this shares with the glowing structure and separates it sharply from any broadcast. It is passive. No one has to keep it running. A pollutant does not need a transmitter or a tended machine. It is a stain that outlasts the spill, sitting in the atmosphere long after the factory that made it have gone quiet, long after the hands that built the factories are gone. It could persist as evidence for ages after the civilization that produced it ended, a chemical residue of industry, drifting in the light of a world where perhaps no one remains. Here again, the same pattern surfaces that has haunted every case in this part. The evidence that lasts the longest is the evidence least tied to anyone still being alive to produce it. A message needs a sender. A stain in the air needs only to have happened once. And then it simply remains, telling its story to the starlight, whether or not anyone is left to have told it. And a physical object is more durable still. We touched on this earlier and can now name it plainly. Our own Voyager probes are already leaving the solar system, and in the deep future, they will drift among other stars as silent artifacts of a civilization, us, that may or may not still exist when some other mind finds them. A probe does not broadcast. It does not need power. It does not need makers. It simply endures, coasting through the dark for millions of years. A durable techno-signature that could outlast its entire species. If that is true of our crude probes, it could be true of artifacts far grander, launched by civilizations far older. The most lasting evidence of intelligence in the galaxy may not be anyone's message at all. It may be their debris, their infrastructure, the things they built to last, still radiating the plain fact of their existence, long after the last of them fell silent. There is one more factor that tilts the odds toward the unsettling reading, and it has to do with time, specifically with how long any civilization stays loud. Think about our own case. We have been detectable in radio for only about a century, and already the way we use the spectrum is changing. Our transmissions grow more efficient, more contained, leaking less into space, as the wasteful broadcast towers of the past give way to tighter, quieter technology. It is entirely possible that a civilization's window of accidental loudness, the span during which it floods space with detectable noise, is brief. A single loud afternoon in a very long life, opening and closing in a few centuries before the civilization goes quiet again. Not because it died, but because it grew more careful with its energy. Now weigh that against everything we have built. If the noisy phase is short, but the durable evidence, the beacon left running, the structure still glowing, the stain in the air, the artifact still coasting, lasts far longer, then at any given moment there is more old evidence adrift in the galaxy than there are civilizations actively making new evidence. The relics outnumber the broadcasters. The tracers outlast the transmitters. And that means that when something finally reaches us, the odds quietly favor its being one of the lingering, long-lived kinds rather than a live voice caught mid-sentence. Because the long-lived kinds are simply more plentiful and more likely to still be crossing space when we happen to be listening. It does not prove anything about any single signal, but it bends the whole probability of the thing, gently and relentlessly, away from greeting and toward remnant. Line the four cases up and the pattern is unmistakable, and it points somewhere we did not expect to go. A living civilization on the other end of the line. An automated beacon outliving its makers. Accidental leakage from a moment already finished. A durable structure or artifact glowing on after extinction. And here is the quiet, disturbing thing they have in common. The longer lasting the evidence, the more likely it is to reach us. And the more likely it is to have outlived whatever created it. The signals and structures most capable of crossing the vast gulfs of space are precisely the ones most capable of surviving the death of their makers. Detectability and durability are the same property, which means the very thing that makes a piece of evidence reach us across 1,000 light years is the same thing that makes it likely to arrive as a remnant rather than a greeting. We came into this part hoping to read the sender. We are leaving it having realized we can only read the bottle. The direction, the age, the structure, even the message, all of it is history, sealed and dated, silent about the present, separated from any reply by centuries we may not be able to span. And the most enduring evidence of all, the structures and the artifacts, may reach us specifically because their makers are no longer around to switch them off. If that is true, if the strongest, farthest reaching, longest lasting evidence of intelligence is also the evidence most likely to outlive the intelligence itself, then something fundamental about the whole idea of first contact begins to shift beneath our feet. It stops looking like a meeting. It starts looking like a discovery of something left behind. And that changes not just what we would find, but what the finding would mean. For them, and for us, and for the strange and lonely position we would suddenly occupy in a universe we finally knew we did not have to ourselves. That is the realization we now have to face. Let us gather what we have built, because we have quietly walked ourselves to the edge of something enormous, and it is time to look straight down into it. We began with a signal that felt like the start of a conversation. We turned it, at the outset, into a message from the past, sealed by distance, carrying certain proof of intelligence and total silence about the present. We watched how brutally the universe erases such signals, and how the few that survive the crossing are the deliberate, powerful, durable ones. The ones built to last. And then we laid the whole thing bare. A confirmed signal can tell us where it came from and when it left, and even perhaps what it was trying to say, and it cannot tell us the one thing we most want to know, whether anyone is still there. We ended on 4 possibilities and on the quiet, disturbing thread running through all of them. Pull that thread now, all the way, because it leads somewhere the human mind resists going. Here is the escalation. A civilization does not have to last long to be detectable. It only has to be loud once. It only has to build one beacon, or one great structure, or leak strongly for one bright century. And then that evidence, the signal, the glow, the artifact, sets out across space at the speed of light and keeps going, entirely independent of whatever happens next to its makers. The evidence and the civilization part weighs the instant the evidence leaves. From that moment, they are 2 different objects with 2 different fates. The civilization lives its life, whatever that life is. Flourishing, changing, collapsing, enduring, vanishing, bound to its own world and its own time. The evidence simply travels, indifferent, carrying forward the frozen fact of a single moment across a gulf so wide that the 2 may never again have anything to do with each other. And this is the thing. A signal can easily outlive the civilization that made it. A structure the size of a solar system can glow with waste heat for ages after its builders are gone. A probe can coast through the dark for millions of years after its makers have turned to dust. So it is not merely possible, but in a real sense, likely, that the evidence reaching us has outlasted its source. A short-lived spark and a long-lived signal produce exactly this. Proof of intelligence arriving long after the intelligence itself has ended. Not because intelligence is doomed, not because every civilization destroys itself. We have said nothing of the kind, and the physics requires nothing of the kind. Simply because the messenger is more durable than the sender, and travels farther than the sender ever could, and keeps its promise to arrive long after the one who sent it has stopped being able to keep any promises at all. Which means the first evidence of intelligence we ever confirm may not be a hand reaching toward us. It may be something left behind, And once you say that plainly, the whole picture reorganizes itself around a different idea. An idea we have been circling for 3 parts and can finally name. What we would be doing on that night and in all the years after it is not communication. It is archaeology. Think about what an archaeologist actually does, because the parallel is exact, and it is worth walking through slowly. An archaeologist stands in the ruins of a city that no one has lived in for 1,000 years, or 3,000, or 10. They find a wall, a tool, a painting on stone, a script pressed into clay, and from those remains they reconstruct a world. They can tell you how these people built, what they ate, what they feared, which gods they carved, how they organized their days, sometimes even what they wrote and what they believed. They can come to know a vanished civilization in extraordinary intimacy. More, sometimes, than that civilization knew about itself. And there is one thing the archaeologist can never do. No matter how complete the ruin, no matter how legible the script, no matter how brilliant the reconstruction, they cannot speak to anyone who lived there. They cannot ask a single question and receive a single answer. The people are gone, and the gulf between the archaeologist and the living city is not a gulf of space that a journey could cross. It is a gulf of time, and time only runs one way. The ruin is a message from the past that cannot, by its very nature, become a conversation. You can interpret it. You cannot answer it, and it cannot answer you. That is what a confirmed interstellar signal would be. A ruin in radio light. We would stand over it exactly as the archaeologist stands over the buried city, able, with patience and genius, to read an astonishing amount, and unable, no matter what we do, to reach across the divide and touch a living mind on the other side. We would learn where they lived. We would learn when. We might learn how they thought, what they had discovered, how they pictured the same cosmos we picture. We might, if the message was built to be understood, come to know them with a depth that would move us to tears. And through all of it, the one act that would make it a relationship rather than a study, a reply that reaches a living listener and returns, would remain closed to us, walled off not by any failure of our instruments, but by the plain geometry of a universe in which nothing outruns light and time does not reverse. We usually imagine first contact as a meeting. 2 civilizations, finally aware of each other, beginning the long work of understanding across the void. But a meeting requires that both parties exist in the same present, and the whole burden of everything we have said is that the present is exactly what distance takes away. Across 1,000 light years, there is no shared present. There is only our present and their past, stitched together by a signal that took 10 centuries to arrive. First contact, if it comes this way, is not 2 civilizations meeting. It is one civilization discovering the traces of another, reading them, marveling at them, mourning them perhaps, while the other remains permanently on the far side of a divide that no ship and no signal and no act of will can close in any human span of time. And I want to be very careful here. At the place where this is easiest to get wrong, because the pull toward the darkest reading is strong and it is not earned. To say that first contact may be archaeology is not to say that the senders are certainly dead. It is not to say that intelligence inevitably dies, or that civilizations burn out, or that the galaxy is a graveyard. We have no basis for any of that, and I will not smuggle it in at the end. The senders may be alive. They may be flourishing at this very moment on a world we will never reach, 1,000 years older than the message we caught, entirely unaware of us. The archaeology framing is not a claim about their death. It is a claim about our knowledge, about the permanent limit on what we could learn from the evidence alone. Which is why we have to handle that one heavy word honestly, one last time, and then set it in its proper place. Dead. When we say a civilization behind a signal might be already dead, the word is doing more work than it can honestly bear, because it hides at least 4 very different fates inside it, and the signal cannot tell us which, or whether any of them apply at all. It could mean true extinction, the being simply gone. It could mean collapse. Still there, but fallen back to a condition where they no longer build the kind of technology that shouts across the stars. It could mean abandonment. The particular beacon, the particular structure, the particular outpost that reached us went silent long ago, while the civilization itself moved on, or moved elsewhere and simply stopped tending this one lamp. Or it could mean the gentlest and perhaps most common thing of all, the end not of the beings, but of their detectable phase, the brief window in the life of any technological species, when it happens to be radiating in a way a neighbor could catch. A window that may open and close in a geological blink while the civilization goes on living, quieter in ways we could no longer hear. Any of these, or none. The signal is silent on the matter, and its silence is not evidence of the worst. It is only evidence of our limit. So the picture is not a graveyard, and I will not let it become one. The honest picture is stranger and, in a way, harder to hold, because it refuses to resolve. We would know with certainty that another intelligence existed. We would not know and could not know whether it exists still. Both halves of that are true at once, and neither cancels the other. And we would have to live in the space between them. The certainty and the uncertainty pressed together, permanently, with no instrument capable of prying them apart. Now let me name the thing that I think is the real center of all this. The part that unsettles more than any talk of extinction, because it is quieter and it does not go away once you have seen it. The most disturbing thing about the first alien signal may not be anything it says. It may not be its content at all. Not the message, not the mathematics, not whatever picture of themselves the senders chose to send. The most disturbing thing may be a single number that comes attached to it before we decode one bit. The date. The date encoded silently by the distance. Because the distance is not optional information. It is not a detail we might or might not recover. The moment we locate the source, the distance is fixed, and the moment the distance is fixed, the age of the evidence is fixed with it, whether we want it or not. 1,000 light years away means 1,000 years old. There is no version of the discovery in which we get the signal without also getting the date stamped on it by the depth of space it crossed. And that date is the thing that turns a greeting into a relic. It is the number that tells us before we have read a word that we are looking at the past, that whatever we are about to learn about these beings, we are learning about them as they were, across a gap of time we did not choose and cannot close. The content might be wonderful. The content might be the most beautiful thing our species ever received. And underneath it, unremovable, would be that cold arithmetic of distance, quietly informing us that the beings who made this beautiful thing are, by now, unreachable, separated from us not by miles we could someday cross, but by centuries that no crossing can undo. That is the ache at the heart of it. Not horror, not the certainty of death. Something more like the ache of the archaeologist who reads a farewell letter in a dead language and understands, in the moment of understanding it, that the person who wrote it has been beyond any answer for 1,000 years. The letter is legible, the writer is gone from reach, and the very act of reading it makes the distance between you sharper, not smaller. Hold both sides of what this would mean for us, because they arrive together and they do not soften each other. On one side is the answer to the oldest question our kind has ever asked. Since the first human looked up at the night and wondered whether anyone was looking back, we have carried that question without an answer. Are we alone? Every generation has asked it. Every culture has answered it with story, because it could not answer it with fact. And on this night, at last, the answer would arrive, and it would be no. We were never alone. Somewhere across the dark, another mind arose on another world, looked up at its own night, asked its own version of the same question, and built something to send its answer outward. That is not a small thing. That is arguably the most profound piece of knowledge our species could ever acquire. That consciousness is not a freak accident confined to one pale world. That the universe has done this at least twice. That we are members, however distant, of a company we did not know we had. For all of history we have wondered. After this night, we would know. And on the other side, inseparable from it, is the second piece of knowledge that comes in the same breath. We would know we were not alone, and we would know we could not reach them. We would hold the proof of company and the impossibility of contact in the same hand. The universe would answer that ancient longing and, in the identical gesture, close the door on the thing we would most want to do with the answer. To say something back, to be known in return, to turn the discovery into a relationship. We would learn that we have neighbors and that the neighbors are, in every sense that a conversation would require, out of reach, present enough in the evidence to be certain of, absent enough in time to be unreachable, known and unanswerable at once. There is a particular loneliness in that which is worth sitting with, because it is not the loneliness we feared. For centuries, the frightening possibility was that we might be alone. The only mind, the only watchers, a cosmic accident with no company anywhere. This is a different loneliness, and in some ways, a heavier one. It is the loneliness of knowing the company is there and always was there, and that the distance between us is not the kind that effort closes. It is the loneliness of a full house heard through a wall too thick to shout through. Not the silence of an empty universe, but the silence of a crowded one you cannot join. We would go from wondering whether anyone shared the cosmos with us to knowing that someone did, and that the sharing would never become a meeting. That is not the answer anyone imagined. It is stranger and quieter and, I think, truer to the universe we actually live in than any of the fantasies we brought to it. There is one more turn of the screw in this, and it is the strangest of all. The knowledge might not even be mutual. When we detect their signal, we learn that they existed. But they may never learn that we existed at all. If they sent a beacon 1,000 years ago, and then fell silent, they went to their silence never knowing whether anyone caught it, never knowing us, never suspecting the particular world that would one day strain to hear them. And if our reply arrives at an empty sky, or at a people who have changed beyond recognition, then the entire relationship, such as it is, runs one way. We would know them. They would not know us. We would mourn in whatever way a civilization mourns, for beings who never grieve for us because they never knew we were coming. That is an asymmetry with no comfort in it, and no cruelty in it either. Only the plain arithmetic of a universe where light is slow and time is long. Two intelligences can share a cosmos, can each look up at the same darkness and ask the same question and send the same answer outward, and still pass each other entirely, each knowing the other only as a trace, or not at all. We imagined first contact as two minds turning to face each other. It may be closer to two people walking the same road in opposite directions through a fog so thick that one sees the other's footprints, fresh in the dirt, and calls out, and hears nothing, and walks on. And notice what this does to the whole idea we started with. The reflex in that first room, the instinct to reply. We would still reply. Of course we would. We would point our transmitters at that star and send something outward, because it is unbearable not to. Because the impulse to answer when spoken to is written deep in what we are. But we would send it understanding what it is. Not a message in a conversation, a message pointed outward with no hope of return, aimed at a horizon we will never reach, arriving in 1,000 years at a place that may or may not have anyone left to catch it, possibly to be found the way we found theirs, as a relic, by someone reconstructing us long after we too have fallen silent. Our reply would be an act of faith, not an act of communication. A note left for the future rather than a word to a listener. And there is something dignified in that. In answering anyway. In refusing to let the impossibility of the exchange be a reason for silence. But it is not the triumphant back and forth of first contact dreams. It is one lonely civilization laying its own evidence on the same current that carried theirs, trusting the darkness to deliver it, knowing it will not live to learn whether the darkness did. And if we truly grasped what we were doing, it might change the character of the reply itself. A message sent into a conversation is written for the one who will answer. A message sent across a gulf that no answer can cross is written for a stranger we will never meet, in a future we will not live to see. That is a different kind of writing entirely. It is the writing of a time capsule, something composed not to be replied to, but simply to be found, and to say on behalf of people long gone by the time it is opened, we were here, and we saw you, and we understood what it meant that we could not reach you. There is a peculiar generosity in that. To answer knowing you will get nothing back, to spend the effort and the energy and the care on a note whose only possible reward belongs to someone you will never know, is to act on behalf of a future that owes you nothing. It is the opposite of a transaction. It is a gift flung into time, and it would carry a humility our first contact dreams never included. We would be composing our reply in full awareness that we, too, are mortal as a civilization, that whoever eventually receives our answer may receive it exactly as we received theirs, as a relic, reconstructing us from a signal that outlived us, wondering as they read it whether anyone who sent it still remained. We would be writing not as the confident senior partner in a cosmic dialogue, but as one more voice in a long relay of the vanished, each entrusting its words to the same silent distance, none of them ever hearing whether the words arrived. To reply at all, under those terms, is one of the most quietly hopeful things a species could ever choose to do. We have, in fact, already begun to do exactly this, without fully facing what it means. Our Voyager probes are leaving the solar system now, carrying their images and their sounds, coasting towards stars they will not reach for tens of thousands of years. We built them in part as messages, as evidence of ourselves, cast outward. And whoever might one day find one of them will find it precisely as an artifact. A durable trace of a civilization glimpsed across an unbridgeable gulf of time to be studied rather than answered. We are already, in our small way, sending archaeology to the future. We just have not let ourselves feel that the first evidence we receive would arrive the same way. So let me bring this all the way to rest, because everything we have built points to a single place, and it deserves to be said cleanly. The first confirmed alien signal may not begin a dialogue. It may end instead hour-long solitude, and in the same stroke reveal exactly how uncrossable the distance between minds can be. It would be, most likely, not an invitation, but a remnant. Proof that another intelligence once looked into the universe, built technology, and transmitted evidence of its own existence outward into the dark. Proof of company, delivered across a gulf so wide that the delivery itself may have outlived the sender. We would not be receiving a call. We would be excavating a ruin made of light, reading, with all the care and wonder we could bring, the traces of a civilization we can know but cannot reach, whose present condition the universe simply will not tell us. And I want to end on the honest shape of that, without flinching toward false comfort, and without collapsing into false despair, because the truth is balanced precisely between them, and the balance is the point. We would not know they were dead. Do not let anyone tell you the signal would prove that, because it would not. They might be alive out there right now, 1,000 years past the moment we caught, living lives we will never witness under a sun whose light we will not see for centuries more. The uncertainty is total, and it is permanent, but we would also not be able to reach them. Not because we failed, not because our machines were too weak, but because the universe is built in such a way that distance is time, and time between the stars is measured in the rise and fall of whole civilizations. And no reply we could send would arrive before eras are turned on both ends of the line. That is the contradiction we would have to carry. We were never alone. We may never make contact. Both true, both at once. The oldest question answered and the deepest wish denied in the very same signal. The universe, if it ever speaks to us this way, will not hand us a conversation. It will hand us a relic, dated by the distance it crossed, legible perhaps, luminous perhaps, and silent on the only question that a conversation could have answered. It will tell us, at last and beyond doubt, that we are not the only ones who ever looked up and wondered. And it will leave us standing over that knowledge the way we have always stood over the ruins of our own lost cities, certain that others were here, moved beyond words by the traces they left, and separated from them by a gulf that all our reaching cannot close. We spent our whole history afraid the night sky might be empty. The stranger, quieter truth may be that it is full of company. We arrived too late in time to answer, evidence still travelling toward us from minds that looked out at the same darkness, asking the same question, and sent their proof of it into the void without ever knowing whether anyone, anywhere, would one day be listening. And that is the part we were never prepared for. We spent so long dreaming of the moment we would be found that we never asked what it would mean to be the ones who arrive, to be the listener at the end of the long wait, the one who catches the message and understands it and cannot answer it. We imagined ourselves as one half of a meeting. We may turn out to be something quieter and stranger instead, the witness who came late and stayed and finally understood. If that signal comes, we will be listening. and we will finally know we were never alone. We just may never get to say it back.